Welcome to Grade 9 Mathematics class. I'm Sir Louis D. Gaceta, and the topic for this session is all about solving quadratic inequalities. Remember, to solve quadratic inequalities, the following steps can be followed. Step 1. Transform the given quadratic inequality into quadratic equation in standard form. Step 2. Solve for the roots or critical points. You may use the different methods in solving quadratic equations. Step 3. Use the roots to obtain the intervals. Step 4. Choose a test point in each interval to determine the solution set. And Step 5. Graph the solution set. For the given direction, solve the given quadratic inequality x squared plus 3x minus 10 is greater than 0. Step 1. Transform the given quadratic inequality into quadratic equation in standard form. The corresponding quadratic equation of the given quadratic inequality x squared plus 3x minus 10 is greater than 0 is x squared plus 3x minus 10 is equal to 0. Step 2. Solve for the roots or critical points. You may use the different methods in solving quadratic equations. Say for example, we're going to use the factoring method. The factors of the quadratic expression x squared plus 3x minus 10 are x plus 5 and x minus 2. So we have the quantity of x plus 5 times the quantity of x minus 2 is equal to 0. Then apply the zero product property. We have x plus 5 is equal to 0. We have x minus 2 is equal to 0. Solve for the values of x. X is equal to negative 5. X is equal to 2. Step number 3. Use the roots to obtain the intervals. The intervals are x is less than negative 5, negative 5 is less than x less than 3, and x is greater than 2. Step number 4. Choose a test point in each interval to determine the solution set. For the interval x is less than negative 5, let x equals to negative 6. Substitute the value of x, which is negative 6, to the given quadratic inequality, which is x squared plus 3x minus 10 is greater than 0. We have the square of negative 6 plus 3 times negative 6 minus 10 is greater than 0. Then simplify. 36 minus 18 minus 10 is greater than 0. Then 8 is greater than 0. So the statement is true. For the interval negative 5 is less than x less than 3, let x equal to 1. Substitute the value of x, which is 1, to the given quadratic inequality x squared plus 3x minus 10 is greater than 0. We have the square of 1 plus 3 times 1 minus 10 is greater than 0. Then simplify. We have 1 plus 3 minus 10 is greater than 0. Negative 6 is greater than 0. So the statement is false. For the interval x is greater than 2, let x equal to 4. Substitute the value of x, which is 4, to the given quadratic inequality x squared plus 3x minus 10 is greater than 0. We have the square of 4 plus 3 times 4 minus 10 is greater than 0. Simplify. We have 16 plus 12 minus 10 is greater than 0. 18 is greater than 0. The statement is true. Therefore, the solution set of the inequality x squared plus 3x minus 10 is greater than 0 is x such that x is less than negative 5 or x is greater than 2. Step 5. Graph the solution set, which is x such that x is less than negative 5 or x is greater than 2. Plot the points corresponding to negative 5 and 2 on the number line. Since the indicated symbols in the inequalities are less than and greater than, use hollow circles. So for the interval x is less than negative 5, the values of x are less than negative 5. The numbers less than negative 5 are located on the left side of negative 5. For the interval x is greater than 2, the numbers greater than 2 are located on the right side of 2. That is the graph of the solution set x such that x is less than negative 5 or x is greater than 2. That is the end of this session. Thank you for watching and listening.